section, we're actually going to be looking more at parabolas and their graphs and their equations. So on page 153, we're going to be looking at writing quadratic equations from their special key features. So take a look at each of these graphs. In your book, A, B, C, and D. And then look at the functions that are below and take a moment and see if you can match or guess which ones would go with the others. Does anybody have an idea of which one would go with A? I hope you guessed that since it's opening up, it's y equals x squared, and it's going to be positive because it's opening up. So the only one that has a y equals and a positive coefficient in front is this one right here. So I agree. That one would go with A. Notice that B opens down. So it would go here. So by elimination, notice that the other two parabolas are opening left and right, and the other two equations that we have available are x equals instead of y equals. So can you make a guess of which one would go with C? C is positive, and think about which direction on the graph. Sorry about that, I was grabbing something behind me. My chair speaks. So C is positive, opening to the positive side of the x-axis. So that one's going to be matching with the positive here, which would be C. This is an x equals, and it's opening to the left. If anyone else had a different way of matching them up or thinks they have a different reasoning, we can hit pause and go over that. So now, notice some things about this, and we're not going to go over every single part of this, but what was the same on all of these? Well, they all started with 1/4, right? And so they all had kind of a similar, how wide or narrow they were. Now, how they moved is something a little bit different. Notice that on A and B, they're almost reflections of each other over the line y equals -1. If you put them right on top of each other. But everything else is the same. What would be the vertex of A? Well, the vertex is that turnaround point, so its vertex would be 2, -1. What's going to be the vertex of B? Well, it's also 2, -1. So notice the vertexes are the same. And if we look at the equations for A and B, x minus 2. Think about how that's going to move the graph, kind of reflect back on absolute value equations. X minus 2 would move us right 2, and that moved me down 1. So look at these graphs. Right 2, down 1. Right 2, down 1. Now let's compare C and D. C and D are reflections on the line x equals 1. And let's see if we can write down where their vertexes are. Well, this one's at the point -1, 2. And this one has a vertex at the point -1, 2. So they have the same vertex. They're opening up just as wide, but one's opening to the right and one's opening to the left. Let's look at the equations and see if we can see how those would be related. So here's the equations for C and D. They both have a coefficient of 1/4. One's positive, one's negative. Can you tell from the equation where the 2 and the negative 1 come from? Or the negative 1 and 2? Notice that they're switched here. The 2 is being subtracted from the y, while here it was being subtracted from the x's. So that's kind of our little introduction to the shape of parabolas and how their equations relate. Let's see how we did. Which equation do you think represents this graph? Well, let's talk through it after you've had a chance to think. They all have a negative in front, and it's opening down. They all have the same number in the front. How has this graph moved from the origin? Well, it's left 2 and up 4. So let's see who can remember left 2 and up 4. If I'm moving left 2, what's going to be inside the parentheses? Right, it's x plus 2. So we've already eliminated this one. Up 4 would mean we add 4 at the end. So that's the correct one. Number 9. Let's think about that. Can we tell which direction this graph is going to open without doing anything else? Well, it's an x equals instead of a y equals, and it's negative. It's going to open to the left. Now, all of these graphs are considered parabolas. And a parabola is actually defined as a set of points that are the same distance from a point called a focus and a line called the directrix. So let's see what that means, because those are some funny words. The focus of graph A, shown below, is 2, 0. The directrix is this horizontal line, y equals negative 2. So let's test this theory that every point is the same distance from the focus as it is the directrix. So can we find the distance between the point negative 2, 3, negative 2, 3, this point right here, and the focus? So remember, we have the distance formula. The distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We have negative 2, 3, and our focus was the point 2, 0. So let's make this one be x1, y1, and we'll let 2, 0 be x2, y2. And it doesn't matter which point you pick for your x1, y1 and which point you pick for x2, y2, as long as you're consistent. So here's my distance. x2 is 2 minus a negative 2. And we're going to square it. Plus y2 is 0 minus y1, which is 3. And then we're going to square it. So 2 minus a negative 2 is going to give me 4. So we have 4 squared plus 0 minus negative 3 0 minus 3, which is going to give me a negative 3 squared. 4 squared is 16. Negative 3 squared is 9, which gives us a 25. And the square root of 25, and remember, since we're talking about distance, we're only concerned about a positive distance. Our distance is 5. Let's see how far away that point is from the directrix. Now, we could use the formula again, or we have the point drawn on the graph. How far away is the directrix from that point? 1, 2, 3, 4, 5. So the distance between the point and the directrix was 5 as well. So they are exactly the same. Let's see if it works even on the ones that are horizontal. The focus on this one is negative 2, 2, and here's our directrix at the line x equals 0. So let's take a point that's on the parabola. There's a point at negative 2, 4. Can we tell how far away it is from the focus and the directrix? Well, actually, this one's an easy one to do straight from the graph. How far is it from the focus? 1, 2 steps. How far is that point, the point negative 2, 4, from the directrix? 1, 2. What about negative 5, negative 2? So here's the point, negative 5, negative 2. That one's not so easy for finding the distance. Now we can use the distance formula. Distance formula is x2 minus x1 squared plus y2 minus y1 squared. Remember, we've got this point. Let that be x1, y1. And then we have our focus. The focus was that point, negative 2, 2. So when we plug into the distance formula, x2 is negative 2 minus x1, which is a negative 5. Well, that's really going to give me plus 5. y2 is 2 minus y1, which is a negative 2. If I subtract a negative 2, that's adding 2. Negative 2 plus 5 is going to give me 3 squared. 2 plus 2 is 4 squared. 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. So that distance is 5. Let's see if that point is 5 units from the directrix. Here is that point. 1, 2, 3, 4, 5. So the distances are the same from any point on that graph. So let's look at some other key features. On this parabola, we have marked where the focus is and where the directrix is. Draw and label the axis of symmetry. Remember, the axis of symmetry splits a parabola right in half. So straight down the middle. So there's our axis of symmetry. What line, what's the equation of that axis of symmetry? Well, it's a vertical line. So that's an x equals, and it's at negative 2. Draw and label the vertex. The vertex was right there. And that is the point negative 2, negative 3. Notice that our directrix is horizontal and our axis of symmetry is vertical. Also notice that your vertex is lying straight on your axis of symmetry. It's where the axis of symmetry meets the parabola. Now, what's another way we could have found the vertex? Remember, if it's equal distance between the focus and the directrix, it's got to be the halfway point between the two. Now, when we don't have everything marked down, we're going to look at a general parabola. And actually, I'm not loving the way they have that set up. Let's flip over to page 160. To be able to write general equations of parabolas given certain information, we have to have some rules. Well, this doesn't have to be perfect because this is just general. When we have a vertical axis of symmetry, in other words, our graph is opening up and down. Here's that axis of symmetry. It's vertical. Let's call the vertex the point HK. So my axis of symmetry, remember, it's a vertical line, so it's an x equals. It's going to be the line x equals h because it's going straight through that vertex. Now, remember also that we're going to have a directrix, which is going to be a horizontal line right here. And we're going to have a point that's called the focus. The distance to the focus is called P. So notice how they word it here. If you take your vertex and you go up P spaces, that would be H, because the x variable would stay the same, and you take your y and add P to it. Now, if the distance to the focus is called P, and it's the same distance to the directrix, this would also be P. But instead of adding P, because we're going up, we're going down, so we would subtract it. So you would get y equals k minus p. Now, in our equation, the way we can figure out what that distance p is this coefficient right here. Now, remember, x minus h is in the equation because we're moving right h and up k. The coefficient here is actually 1 over 4p. Now, there was a spot in the notes for us to go over the proof of that, and I will video it, but I didn't want to take the time in class to actually do that. Now, for the horizontal ones, everything is very similar. We still have our vertex at HK, but let's see what's different. Axis of symmetry is now a horizontal line. So instead of an x equals, it's going to be a y equals. So which part is the y equals there? It's going to be y equals k. The distance to the focus and the directrix is still p steps. So am I adding and subtracting p to the x value or the y value? So this would end up being my focus at h plus p, comma k. And this would be my directrix. And that's a vertical line, so it's an x equals. That's not equal to the h value where we were right there. We had to go backwards p steps, so that'd be h minus p. Now all of these are in this table here. And let's look at how we can use them to graph, to write equations of lines. So let's start with the first one on the next page. Axis of symmetry is y equals 0. So y equals 0. And the vertex is 0, 0. And the directrix is x equals 1/2. So let's think about this. Is this going to be a vertical parabola or a horizontal parabola? Axis of symmetry is a y equals. It is sometimes helpful to graph or make a quick sketch. So here's my x and my y axis. My vertex is at 0, 0. If my axis of symmetry is the line y equals 0, then I've got to be a horizontal. The directrix is x equals 1/2. So 1/2, that's positive. That's going to be right here. Now remember, our graph, look at it. It's always running away from the directrix. It's centering around the focus. So this has to be opening this way. Now, how far is it from my vertex to the directrix? Well, if it's at the line x equals 1/2, then our p-value is 1/2. Now, we said that it was a horizontal, so let's look at that generic form of a horizontal parabola. X equals 1/4p times y minus k squared plus h. So let's think of everything we know to be able to write that. We need our h and k. Where did those come from? Well, those are from the vertex. We also need the p-value. Oh, we already found that. Now, we also need to put on here a negative if it's opening the opposite way. Since it's opening left, then that would be a negative coefficient. So negative 1/, what do I get when I do 4 times 1/2? I'm going to get a 2. Y minus k, k is 0, so that's just y, squared, plus h. Well, h is 0. I mean, I could write plus 0 if I wanted. I really don't feel like it. So we're done. Let's do B. Now B, they gave us a couple of points. I'm going to come over here to, well, this is okay. We can do it right here. 3, 4, and 3, 6. Okay. So 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, so this is the vertex, and this is the focus. So I'm going to be opening around the focus. So that means I'm a vertical parabola. How far is it from the focus to the vertex? Well, that's 3, 4, and 3, 6, so P is 2. Now remember, the vertex, this point, is the point HK. So if 3, 4 is my vertex, then 3 is the H, and 4 is the K. And this is opening up, so it's a vertical parabola. y equals 1 over 4p times x minus h squared plus k. So we plug in what we know. Y equals, the p is 2, the distance from the vertex to the focus, so 1 over 4 times 2 is 8. X minus the h value plus k, which is 4. And notice again, x minus 3, we're moving right 3, up 4. Number C, the vertex is negative 2, 1, and the directrix is at y equals 4. So, let's see where that is. Negative 2, 1 is the vertex. 2, 3, 4. Y equals 4 for a directrix. That's a horizontal line there. So I've got to be going away from it, and here's my vertex, so I've got to be opening down. So we know we're going to have a negative coefficient. How far is our distance from the vertex to the directrix? Well, here's a 1, so it's 3 steps. Our p is 3. Negative 2 is going to be the h, and 1 is the k. We are again having a vertical one, parabola, but since it's opening down, it's going to be negative. So this is going to be y equals negative 1 over 4 times p. P was 3, so 4 times 3 is 12. X minus h. Well, the h was a negative 2, so when I do x minus a negative 2, that's x plus 2. Plus the k, and that would be 1. Focus is at negative 4, 0, and the directrix is at x equals 4. Uh-oh, they switched up on us. This one I am going to do on my grid over here. What didn't they give us that they've been giving us on the other problems? They didn't give us the vertex. All right, so let's go to the focus. It's at negative 4, negative 1, negative 2, negative 3. Here it is. And the directrix is x equals 4. X equals, that's a vertical line. So, okay, this is the focus. And this is the directrix. My vertex, every point on the parabola has to be the same distance from each of them. So my vertex is going to be halfway between them. Oh, there's my vertex. Now remember, it's going to go away from the directrix and kind of hug the focus. So the graph is going to do something like this. So let's see what all we know now. We know it's horizontal, and it opens left. The vertex is 0, 0. And remember, that's my h and my k. The only other thing I need is p, which is the distance from the vertex to the focus and the distance from the vertex to the directrix. Well, if I count either way, it's 4 steps. So when we get that generic form of the horizontal, remember this was over here, I'm going to write it down again. X equals 1 over 4p times y minus k squared plus h. All we do is plug in what we know. Now we do know it's opening left, so it's going to be negative 1 over 4 times p. Well, p is 4, so that's 1 over 16. Y minus k. K was 0, so that's just a y. Plus h. Well, h was 0 as well. Let's do E. Ooh, E is even bigger, but we can do it. Focus is at 5, 7, and Directrix is at y equals 3, and they're telling us it opens up. Okay, so 5, 7. Oh, I hope I gave it enough room. May have to scoot over a little bit here. 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That's the focus. They're telling us the directrix is a line y equals 3. That's a horizontal line. Here's where y is 3. So it's going here. And it says it opens up. So where's the vertex? Well, remember on here, it was halfway between the focus and directrix. So halfway between is going to be this point right here. That's my vertex. Now remember, it's opening up. So what is the coordinates of that vertex? Well, that was 5, 1, 2, 3, 4, 5. So 5, 5. Okay, so my vertex is 5, 5. This was a vertical parabola that opens up. Last thing we need is the p-value. How far is the distance from the vertex to the focus or the vertex to the directrix? Well, that's 2 steps. So why don't you try? I'll write the generic version of the vertical parabola. You take a moment and try to write the equation while I put the answer up here, and then you can check to see if you're right. On the homework, you're going to be doing the same exact steps.